Welcome guys to today's class. Let's see how to solve this problem on differentiation. We are asked to find the derivative of y, and we have only one y here. So we have to make it subject of formula by dividing with everything by each side. So we'll be having y to be equals to sine squared x all over cos x bracket cos x plus sine x. At this point, it has a numerator and a denominator, so you can use quotient function or quotient rule to solve it. You can also use product function to also solve it. Let's see how to use product function to solve this type of question. To use product function, we have to repackage this. Knowing that tan x is equal to sine x over cos x, we say sine squared x means sine x, then all over cos x times another sine x. This times this will give you sine squared x all over cos x plus sine x. Okay, so we now say that this is equivalent to tan x sine x. Now carry this up, bracket cos x plus sine x raised to the power of minus 1. We'll call this your u and call this your v. This is your u and this is your v. Now, to use product function, we say dy dx. Product function say dy dx is v du dx plus u dv dx. That is about product function. Remember, these are commutative. Addition of two numbers are commutative. So you can say u dv dx plus v du dx, whichever way. Now we have our u to be equals to tan x sine x, then du dx will be equals to, differentiate this u, that will be giving you, pull down the first, tan x, differentiate sine x cos x, plus pull down the second, sine x, differentiate the first. If you are asked to differentiate tan x, you write sec squared x. So if you are asked to differentiate sine x, say cos x, tan x, sec squared x. I take it again. Put the first, tan x, differentiate sine x. Differentiation of sine x is cos x. But when they ask you to differentiate cos x, you say it's minus sine x. Then plus, put down the second, differentiate the first, tan x. Differentiation of tan x is sec squared x. They are constant. Okay? Then you say v is equals to, our v is cos x plus sine x all raised to power minus 1. Then dv dx will be giving you, differentiate the inside. We use composite function because it is a composite function. So you differentiate the inside, differentiate cos x minus sine x, as I said, differentiate sine x cos x, then you now say times carry this power, bring it, then write everything cos x plus sine x, then carry the power, minus 1 will give you minus 2. So that means that you will be having minus 1 cos x plus sine x raised to the power minus 2. Now, this minus 1 will multiply this to be giving you minus times this sine x, minus times this minus cos x. Okay? Then this, because it has power of -2. We replace negative with all over and we write cos x plus sin x, all raised to power of 2. That is our dv dx. Okay, we plug it into the formula and it will go this way. V is cos x plus sin x raised to power minus 1, that is 1 over cos x plus sin x. Then du dx is this. So times du dx is tan x cos x plus sin x sec squared x. Okay, so you now say plus what is your v? We wrote our v and we wrote our du dx. Now what is our u? Our u is tan x sin x times du dx, dv dx. We have written our u. Dv dx is this, sin x minus cos x all over cos x plus sin x squared. Okay, so this will be giving you 1 times this is, now 1 times this will give you this. Remember, tan x means sin x over cos x, and we have cos x here. So we'll replace tan x with what? Sin x over cos x. We now say times cos x, that is for this, plus, so this will cancel this, leaving you with sin x plus sin x plus sin x sec squared x all over cos x plus sin x, then plus this one, you have it, this times this, tan x sin squared x, this times this. Now because that this is sin x, because tan x is equal to sin x over cos x, if you carry this to multiply this will cancel this, leaving you with only sin x. So sin x times sin x will be giving you minus, so this times this will be giving you minus sin squared x. We got it by saying this times this, that is cos x. This, we got it by saying that tan x sin x over cos x, so you use it with this to multiply this. So that means this times sin x times, that is this, times this will be giving you, this will cancel this times this, sin squared x all over cos x plus sin x all squared. Now at this point you check if there are also things you can collect in common. So this will be giving you sin x plus sin x sec squared x all over cos x plus sin x, plus this will be giving you, plus this will be giving you tan x sin squared x minus sin squared x all over cos x plus sine x all raised to the power of 2. Okay, so at this point, all you just need to do is to look for LCM, of the denominators. Looking for their LCM, you have it to be cos x plus sine x raised to the power of 2. So this divide this will give you cos x plus sine x, then write bracket sine x plus sine x sec squared x, plus this divide this will give you the numerator tan x sine squared x minus sine squared x. Please don't make mistake to minus these two. They are not in the same pattern. Here have tan x, whereas this one don't have tan x, so you don't subtract the 2. Now what you do is expand. This times this will be giving you sine x cos x. This times this or cos x sine x. This times this will be giving you plus, that will be giving you cos x sine x. Now remember that sec square x means 1 over cos squared x. That means times cos x sine x. That means this will be multiplying to this. This will cancel to give you cos x. Okay? 1 over cos x will be giving you sec x. So you'll be having here to be sec x sine x, because it's remaining only cos x here. Okay? We have multiplied this, then we'll multiply this, right? Then this times this plus sine squared x, this times this plus sine squared x sec squared x, then plus tan x sine squared x minus sine squared x. Okay, so at this point we will be rounding off. We now have that this will subtract this all over cos x plus sine x squared. So when they subtract, you have this. You have sine x cos x plus you have sec x sine x plus sine squared x sec squared x plus tan x sine squared x all over, you now say that's cos x plus sine x all squared. So this answer is if the option is in terms of sine and what cos. But if the answer is in terms of tan, you remember that here is 1 over cos squared x. Here is 1 over cos squared x. That is mean of sec squared x. So here is something as you writing tan squared x. These two mean tan squared x. Okay? So we have sec x sine x, and this one also means tan x. Yes, this is 1 over cos. When we said sec x means 1 over cos x, and sine x over cos x is equal to tan x. So it means that this is equal to also tan what? X. If the option is in terms of tan. But if it is in terms of sine, cos, and all have you, we can leave it this way. Okay, so that is our answer to the question above. Thanks for watching the video.